let's check to see if the stream's working. Hello? Hello? Perfect. I think this is good. I'm starting to stream. Okay, so I'm gonna put on my music. I don't know if you guys can, I think you guys can hear it a little bit. I'll try to put it up if you want. But this is mainly for me. I am, right now I'm coding, I'm extending this repository to basically allow me to perform a grid search with this machine learning. I'm just trying to get it so that I can, get the GPU running for like a week, and then know exactly what's the best setting for this. Okay, I guess I'll just start explaining what I'm doing. I've never done this before, so don't crucify me. Okay, you can see I have like audio process. There's a whole bunch. This is really coming from the GitHub, so right now I'm just sort of copying it over and then just sort of separating out into things I care about for the things I really care about, and then things I don't care about. I guess like data folder, this stuff doesn't really affect the performance of the model, so I'm just trying to get these guys out of the way. And then seeing the ones like I'm not sure if they'll do anything. Like I was just checking up what the DCT filters are, and it looks like they're just discrete cosine transforms. The only thing I can't find is in the paper which describes this code. I can't find any reference to discrete cosine transforms, so I think I'm gonna leave this one. Well, I'll check it a little bit. It's worth it. Image. I'm using NumPy to generate the lists right now. So this one uses a standard of 40. Let's just see if this works. We'll search from between 30 and 50, and then we'll make the interval 10. So this is discrete cosine transforms. Default 40. We go feature maps. So this is used with residuals. I don't know. Actually, I don't know if this is gonna fail. We'll see. I have a hunch that this will fail. If we use these with, like, let's say a model type that is CNN, Tradpool 2, or one of the other CNNs that isn't a res, because this says right here specifically that it's for the residual networks. Okay, let's close that. The default's 19 to 45, 19 or 45. Okay, I see. Let's see how this is used. I have this running in another computer, and I wanted to see what I used before, like how the variables were input. So annoying. I keep on losing my session though. So let me just make a tmux, a new tmux. Honk session. And let's go into audio, honk, and let's do a search Python. Util. You know what? I misspelled Python. That's why it's not coming up. Python. Here we go. So this is how the input. I just want to make sure I know how to use it correctly. Okay, so that looks good. I'm gonna make a feature map. It looks like it was 19 or 45. I'm going to test between those on a range or an interval of 5. I think I'll just start at 20. I mean, this kind of sucks because I'm starting to get really high in the number, like the search space size. And I'm not quite sure. I mean, there's a couple algorithms I could use to like increase the search space and keep the number of runs the same. But I think right now I'm just trying to get this to work. So if I can get this to work, I can think about adding that later. Okay, so the feature maps. This one's 64. You know, I'm gonna go with the defaults on this one. Should really keep these all the same actually, because they could all be. I'm gonna keep them all lists because I'm gonna search them later, like through the assuming they're all lists, because right now a whole bunch of them are lists. Number of layers. Okay, this is for the residuals. So I think this is another case of this might fail, but I might have to add a if statement in there somewhere. So 6, 13, 24. 7? No, that's... I wonder where 13 came from. I guess we'll just... this is... Oh, well, this is good. This is like a minor one. This is only affected by residuals. I'm gonna actually separate these guys out. Any of these parameters that are for residuals only, I'm gonna separate them out from the rest. And feature map. There's actually a lot for just residuals here. So n layers. We'll start at 10, we'll go to 30, and we'll go up by 10. Number of bells. This one I'm definitely testing because so Mel range, Mel spectrum coefficients are basically binning of an audio signal, but based on the power within specific frequency bins. Should have like a whiteboard or something for these cases. Makes it a little bit easier to explain. But they're used a lot in voice attacks and audio processing. Another one of these is PCENs, which are, I don't remember the thing, but we're gonna get to that because that's definitely gonna be used here. I'll talk about that later. So the number of mels is standard is 40, which is like completely normal. Actually, this is, well, I don't know. We'll start with 40. We'll get up to 120, and we'll go up by. We'll go up by 40. Let's just see where that takes us. So once I run this, I should get like a whole bunch of models output and like the accuracy and the test accuracy. Oh, the test accuracy for it. So I think we'll really get some good results actually from this. Noise probability. So I really like what they did in Honk. Is actually they have some noise folders, and they add that randomly to the clips that are being trained, like right before they're being trained. And so you get like a sort of better, higher quality data set because you're having some random noise or some, like a couple of these silence probability and time shift. Funny thing about silence, we'll get to that in a second. So noise probability, it says 0.8 is the normal. So let's just go with 0.6, and we'll go from 0.7 to 0.8 and then to 0.9. Yeah, I could implement a random search and then like plot it and see if I can, or a gradient descent. It would be interesting. Just randomly, then follow it down. Just we'll make a random walk and then go towards. Fuck. Too much interesting shit to do. That's one of my favorite things about machine learning in general, is that there really is like, just like this thing nests forever. Like the techniques that are used in machine learning to like train the neural networks can be used to train the hyperparameters that you use for the neural networks, and then you can use it again to train the architecture itself of the neural networks, and you can do it to train like what the data is input to it. So there's like, it's got tremendous like nesting capabilities, but it gets to the point where you're literally just throwing compute on the problem, and I think that's I see Google doing that a lot with their stuff. It always looks like they're pumping up because they know compute is going to be probably almost free in the future. See, okay, now we're at silence probability. So I think with silence probability, actually, I have to, I'm going to separate this out, silence and unknown probability, because they're really actually, they're sort of contingent on the size of the desired words. So we want them to be, so what these things do is, silence is actually, it's just that, it's silence. So within a certain percentage point, like 0.80, or I guess like 0.1, every 10 clips you're likely to have one clip that's silent, and the model is trained to detect silence. And so since it's part of the training, technically part of the training set, this silence probability and the unknown probability, which is another, just unknown is like, it doesn't know what's going on here, so it could be noise or a word that it's not training to understand. Those are technically cases within the training data set, so we want to make sure that they're equal. And so if we have the number of labels, then we can just simply calculate the, well, basically, we got, yeah, since there's two, sorry. So n equals 12 divided by 10. Or I guess it's 10 divided by 12. No, that's not what I wanted. Actually, yeah, it's in high performance. Okay. 10 divided by 12. Boom. Yeah, no, it was 12 divided by 10. Excuse me. Definitely 10 divided by 12. I'm doing. Yeah, seems dumb to me, but I'm gonna do it. Minus 2. So that's 10. parentheses divided. Great. So this gives me this, so it's 1 minus this divided by 2. Give me a float. So let's see, 1 minus 0.83 divided by 2. Yeah. That gives me a percentage point that I can use. And I guess okay. Let's just have that be a thing, so I don't have to calculate it twice, because these are going to end up being the same thing. So let's look at time shifts. This is in milliseconds, and the standard is 100 milliseconds. So I'm actually gonna go kind of crazy with this one. So I'm gonna start with 100, but then I'm gonna try to get up to 300, 400, and go by intervals of 100. Okay, so we have, what was that thing? I skipped a whole bunch of these. Let's go back. So con1 pool. Do we have a con1, con2? No. Okay. This one is 2-2. Fucking closed my client again. Damn. Oh, da, da, da. Ba, 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 ba. Okay, so this is what is this? Let's see. Con1 pool with height pool. Actually, one sec. I have to make a scene. Oh. Stream. I'm just making a stream, guys. I'm making a different scene inside of OBS. I don't know if you can hear me actually. I think you can hear me. Okay, well, you should be able to hear me still, but now I can hide if I need to go to the bathroom or something, or do something on my computer, read emails. So let's get back to the convolution 1 pool size. So this says 2-2. I'm just going to go ahead and check how that runs. So let me go back to my TMUX session that I made. So TMUX 1. Perfect. What's going on here? I don't know what just happened here, but let's try to find it again. So, Python, here we go. Let me just run this really quick. Oh, say here? Source activate PyTorch. Okay. That worked out. Let's run it, see if it runs, and then I'll try the con. I want to see how they input that. I think it might be similar to how they do learning rate. You can see the different. I guess I have to install PNC then, because I'm not going to go through all these damn files. Okay, so manage audio, go back, change that. Really got to work on my posture. Yes. Ooh. No, no, no. Okay, there we go. So let's look, see how we install PNC. PCEN. PCEN. Ah. PCEN. Install PCEN. It doesn't look like there's any guide on it. Oh, that's fucking annoying. Well, let's try it. Pip install PCEN. Maybe it's in facilities. It's just not there. No, this is a library. It's funny how they don't say how to install. Let me select the branches. One of the branches might have it. Let's merge though. Damn. What the heck? This is maddening. Why would you do this? Google to the rescue. See, it's what's a per channel energy normalization. Excuse me. Pip. That's pretty annoying. Okay. I really just want to get through this. So I'm going to go back and then where is it? PCEN. Okay. PCEN. This is gonna fucking be used everywhere, man. That's annoying. Whoa. What are you using for PCEN? Hmm. Well, right now they seem to be talking about the differences between the accuracy with PCENs and MFCCs, but they don't mention how to implement it or how to install this specific package, which is freaking annoying. What is called as PCEN? This is maddening. You can't run the damn thing. Shouldn't have to, because nothing will call this, hopefully. Okay, so this should be it. So you can see basically with this Python script, I'm going to generate like a whole list of these, and then I'm just going to run them and then collect the information at the end and save that as a model. And that's going to be my grid search. It's not going to have any learning right now or any of that. I'll probably work on optimizing the speed. But this is working, so I'll just take this. And then I'm going to test the original thing I was trying to test, which was that the output is similar. Because I just want to know for later when I implement that. 2, 2. And if that doesn't fail, then that's probably correct. Although it's not using it's using the mod. It's the pool filter. Actually, let me see this. I think I'm connected online. Abort this connection. Da, da, da. So I'm connecting to a GPU server in the office. Cool. Oh, I'm gonna look at the code on my computer. I don't like using the. I still like the GUI stuff. Ted doesn't like it very much, but I think it's way easier to look at. It's easier on the eyes. So, what are we looking for? Yeah, Chris Test. Man, it's hard to focus on like talking to you guys and working. So sorry if I slow down or I stop talking for a little while. I'm probably just focusing on something. Here's the file. Manage audio. Slow as heck today. Okay, here we go. So let's look for this Cobb one. Oh, what's just happened? Oh. Conv1. Cool. So this is train. Oh, not manage audio. Oops. So now we want to see con1. What? Still? Okay. Global config. Is this changing the config? Is this even reading my thing? Because that would be annoying if it's not. Yeah, it is. This one is a default of 1, and that fucks up my, it doesn't work on my computer. I'm just trying to find where Convo 1 does anything to this code. This has got schedule. Oh, man. Oh. Builder. Okay. Config. Config. Let's get a model really quick. I'm gonna be converting this for like a bunch of uses, and I'd like to have this all set up to run. So I just have to like add compute time and have it generate a couple things like cost curves and shit like that for. Oh, here, look at that. Con 1, boom. Speech model. Excuse me. Oh, excuse me, guys. I had a sort of shitty breakfast. Okay, well, for now, I think I understand this enough. So for this, let's just go with 2, 2, and 4, 4. This one is actually 10 and 4. But then I'm sure this has something to do with the size of the. I'm just gonna leave that as default. And then the stride is gonna be. So the left up one. This will probably very much always stay the same. Well, I could increase it to reduce. Oh, hey, that was cool. Whatever I just did. Oh, that's annoying. No, close that. And 1, 1. Data folder is down here. This is easy, it's whatever the thing is. I think for this one, there's dev every. So this is every epochs. Oh, okay, it's 10. We'll keep it at 10. The dev percentage. It's gonna be 10. And the dropout probability we already set up here, probably. Or down here. Oh, did I not? Oh, yes it is. Okay, we already set it. GPU number. 0. I had multiple GPUs, I could probably set this up to be a thing, and then I could just bin them on every GPU, just like fill up a queue. That's interesting. I don't have multiple GPUs right now though, but I could. I could just spawn a machine. You know, I really should be using Google Cloud Services for this, but I think a lot of the work's already done on this, especially for the sound processing, so I think I'm just continue using this a bit. Oh man, my stream quality is really poor. See what I can do about my stream quality, guys. 'Cause right now it doesn't look good at all. My stream health is really low. What could I do to make my stream health better? Huh. Who fucking knows? Oh, you know what? I still have this set to my other thing. Deep learning, live coding session, and deep learning live coding session. And this is going to be creating a grid search for a keyword detection algorithm. Category, I guess, education, public. Does that automatically save the stream? Can I pause my stream? Yeah, I can. Alright, I'm gonna stop streaming for